No, I'm talking about like, have you taken M1 in your maths unit? Are you aware of what M1 is? Okay, M1 is basically the maths from kinematics, right? Like the maths from projectile motion, the maths from double motion in regarding equations of motion and constant acceleration. These are the concepts entirely based on mechanics 1. Also the concepts from moment and momentum, right? These are the entirely things that are very common with M1. So those of you have already done M1 or is doing M1 simultaneously with physics unit 1, the concepts for unit 1, physics unit 1 would be way much easier. But for those of you who haven't done M1 yet, the concepts would be like a little tricky, but bearable, not that much tough that you won't understand a step of it. So I have a slide prepared. Let me just turn off my camera and then start the class. By the way, my classes will be entirely like my videos, like how I write on the screen, and you just like see on the screen, and I try to explain it with my voice only. So if there is any problem, like you can't understand with the screen showing only, if you want the videos to be on in my class, you can also ask for that. I'll try to manage for another camera to like conduct the class with my cameras on. Right, so this is going to be our first trial class, and we are going to understand few initial concepts of unit 1. And after this class, if you guys decide that if you guys want to continue with my class or not, then you guys can text me in my WhatsApp or in my page or even in my Facebook account, wherever you are connected with me through. And then I will start making a Google Classroom where I'll be uploading the class recordings and the written notes and the lecture slides that I'm going to write inside the class, like the things I'll write inside the class to explain each topic. Those lecture slides will also be added, and we will create a group in Messenger, like Facebook Messenger, so that in case you have a problem, you can't attend a class or anything, you can inform me in that group, right? So I'll check that group more often. Okay, so let's I'm just gonna turn off my video and then let's start the class. Everyone can see my screen, right? Can you all see?
Yes,
Okay. So these are the contents for just chapter 1. This is not the contents for entire unit 1. Unit 1 consists of 2 chapters. As we all know, chapter 1 is the like motions and kinematics, and chapter 2 is regarding of the materials. So in just chapter 1, we are going to deal with these much topics. So in today's class, I'm going to try to cover up part A and part B, like the types of units and quantities and the derivations of quantities, and few basic quantities like distance, displacement, speed, velocity, and acceleration, right? And like from our next class that is going to be started from tomorrow, right? We are going to have 3 weekly classes, Monday, Wednesdays, and Fridays at 10 p.m. So 10:30 p.m. of Bangladesh time, wherever you are joining the class from, according to your time. So yes, so let's start with topic A, types of quantities and derivation of quantities. Let me just turn off my screen for a while, and then I'll again open it. Yes, Mansifa, do you have any problem?
How much time it will take to cover whole unit 1?
I am actually planning to cover unit 1 by the end of like 2nd or 3rd week of February. Is it clear? As I've said in the I have sent you the entire yellow picture where I've stated that there will be topic explanations and mini worksheets on each topic. So what I will do is that I will explain the topics inside my class, and for the worksheet solutions, there will be video solutions uploaded. Like I will make a worksheet for you, I'll give it to you in the classroom, and with like including with that worksheet, you will have a video recording for the explanation for each question. So wherever you stuck at the question, like you can't do question number 4, then you can just look up at the recording and then understand that why things did happen like that or this. Is that clear?
Yes.
Okay, any other questions?
No.
Okay, so I'm assuming that I can complete. Wait 1 minute. Sorry, as I was saying that I'm assuming that Unit 1 would be a little lengthy topic to complete, but for Unit 2, I'll actually need 8 classes to complete the Unit 2 concepts, like all the concepts from Unit 2 that can be done in 8 classes. So we would be done with our Unit 2 by the by the 3rd week of March, and after we have done like by the 3rd week of February or 2nd week of February, as soon as we are done with Unit 1, we will start solving the question papers of Unit 1, and by that side, like we will solve question papers of Unit 1 on one day, and on the other 2 days we'll start solving, like I'll start explaining Unit 2. Simultaneously we'll solve Unit 1 and Unit 2 together, so that we can just cover up the question papers and topic explanation as soon as we can. Right, is there any other questions regarding that, how long it will take for the classes to finish and everything? I think Rashini texted that, Miss, can we get the recordings of this session? Yeah, obviously. I mean, sorry, I didn't understand actually which session. Like, are you talking about the trial class that I'm giving now?
Yes.
Yeah, obviously this class is getting recorded, right? Wait, let me check. Yeah, this class is being recorded and everyone will get a recording for this class. Apple, how are you going to take the mocks? The mocks are going to be online as like the class it is, and for mocks you have to turn on your camera, point it towards your page or sheet wherever you're writing. I will be uploading the question paper inside our Google Classroom, and you have to solve it and then give it to me, like make a PDF of everything and submit that paper in the Google Classroom, just like we did in our coronavirus time, right? There will be 5 mocks for each unit. So in total you can say like 15 mocks, but for each unit there will be 5 mocks. 5 mocks for Unit 1, 5 mocks for Unit 2, and 5 mocks for Unit 3. By the way, as like there are people from Bangladesh and Sri Lanka joining in this class, you can ask me in any language. Like I understand English and Bangla both, right? So anyone can ask me questions in their own preferable language. No one needs to like question me in a language that they are not comfortable in. Anything else that someone has any confusion in that I might clear out before I start the topics? Okay, I think no one has any more questions left, so let me just move to the topic explanations. We were about to start with types of quantities, so wait, just give me a moment. Okay, so in our first class we are going to start with types of quantities. So let me write it down over here. So there are like two types of quantities. One that is based on like if that can be made into anything simpler or not, and the other that depends on magnitude and directions, right? So the first type of quantity that the quantities are characterized in are base or derived quantities. So base quantities are example like distance, mass, time. These are the examples for base quantities, as they cannot be broken down into anything simpler. Like for measuring the distance, you do not need to calculate any other quantities first to get to the value for the distance. Like for example, if you are having to ask to find the distance between these 2 points A and B, you are asked to find the distance.
আপু স্ক্রিন দেখা যাচ্ছে না।
You cannot see the screen? Okay, wait. Oh, I'm sorry. The entire screen thing was off. Sorry.
আবার একটু স্টার্ট থেকে বলবা?
Yeah, obviously. So as I was saying that there will be like every quantities will be categorized into two groups. One category would be based and derived quantity, and the other category would be scalar and vector quantities. So when based and derived quantity, every quantity is based on that if that quantity can be simplified into anything simpler or not. For example, if you focus on distance and speed, right, these are the most common quantities that we all know about, distance and speed. So whenever you are asked to measure the distance of any given points, what do? You take a measuring instrument like a meter ruler or a scale, whichever is preferable to you. You take that instrument and start measuring the distance between any given 2 points. Like for example, these 2 points A and B. You can just use a meter ruler or any scale and measure the distance between A and B. What you are doing is that you are directly working on your quantity. You are directly measuring the value for distance. You are directly getting the value for distance. But when you are asked to calculate speed, what do is that you first measure the distance, and then you using a stopwatch calculate the time or measure the time that a certain movable thing needs to travel that distance. So you need to measure time, and then using these two quantities, distance and time, you have to use another equation, that is speed is equals to distance over time. And then using those values, like for example, you calculated the distance to be 10 meter, and the time taken to travel this distance was like 2 seconds. And then you need to input these values into the given equation for speed, that is 10 over 2, and then you are going to end up with the value for speed. So you have to like work 3 to 4 steps to eventually get to the value for speed. You have to first calculate or measure the distance, then you have to measure the time, then you have to input the values of distance and time into the given speed equation, and then you need to use a calculator to calculate the value for speed. So speed are the type of quantities that are referred to as derived quantities, and distance are the type of quantities that are referred to as base quantities. So from this example, what we understood is that base quantities are quantities that cannot be broken down into anything simpler, or base quantities are quantities who does not have any equation of their own. Like in order to calculate or measure the distance between any two given points, you do not need to use any given equation. You just need to use a measuring instrument and get the value for that quantity directly. But in case of derived quantities, you have to have a certain equation to calculate the value for that quantity, and you have to rely on other quantities to get the value for this type of derived quantities. In our example, speed is a derived quantity because it has an equation, and it also depends on two other different quantities, that are distance and time, right? So these are the basic explanation for distance and time. Now for base quantities, there are only 7 units in our entire physics that are referred to as base, and those are mass. Let me just write it down over here. Examples of base quantities. Examples of base quantities are mass, obviously distance and time, temperature, luminosity, and amount of substance. So we are all familiar with mass, distance, time, temperature, current, right? But we are not familiar with the term luminosity. This is actually a measurement how to calculate the value for the intensity of light. This is outside our A-level syllabus, but we are just learning this term luminosity as an example for base quantities. Nothing else will be asked according to our syllabus about this luminosity topic. Right, and amount of substance is actually moles. If we have chemistry, we are already aware what moles are, right? So moles is also a base quantity. Apart from these quantities, everything that we are going to study in physics are obviously going to be derived quantity. For example, speed, acceleration, velocity, force, and momentum, moment, kinematics, kinetic energy, gravitational potential energy, right? These are all the common quantities that we are very familiar with for our physics, and all these quantities are derived quantity because these quantities depend on other base quantities or even depends on other derived quantities, and they have a particular equation that need to be solved in order to calculate their values. So few examples of derived quantities are first would be speed. So if you just write it down, the equation for speed is distance over time, right? Now distance is again a base quantity and time is again a base quantity, but it's not always the case. Like it's not a fixed matter that for a quantity to be derived, it always have to depend on other base quantities. A quantity can be also called a derived quantity even if it is dependent on some other derived quantities. For example, if you write velocity here, velocity is displacement over time. I didn't wrote displacement to be our base quantities inside the examples of base quantities because displacement, distance are basically the same thing, but just a vector version or a scalar quantity version, right? So they are basically the same thing, but one has direction and the other one doesn't have direction. So this is again a base quantity and time will be again a base quantity. But if you move to the equation for acceleration, we all know the equation for acceleration is v equals v minus u over t, right? Now the term v minus u basically refers to change in velocity, right? Because we are actually subtracting initial velocity from final velocity. So if you just subtract velocity from velocity, what would you get? Change in velocity. So we can just write as a word equation, that is velocity over time. Now velocity is not a base quantity. We have seen just above the example for acceleration, it is a derived quantity. So velocity is a derived quantity and time is going to be a base quantity as usual. So now acceleration is a very unique example for derived quantity because before acceleration we have seen quantities like speed and velocity, both are derived but depends on base quantities. But for acceleration it is a derived quantity and now it depends on another derived quantities. Is my point clear so far? Is everything like understandable so far that I'm telling you about?
Yes.
Okay, so let's move to the other point. So as I've already stated that the quantities are categorized into two groups. One group was this base and derived quantity, and the other group would be vector and scalar quantity. From our IGCSE, we are obviously very familiar with the term vector and scalar quantities, right? What does vector stand for? Like, what is the definition for vector? I know everyone knows, but everyone is like very nervous and everything. There's no need to be nervous or scared about I cannot just reach out to your place and beat you, right? So it's a very friendly class. You all can participate here. Can anyone tell me the difference between vector and scalar?
Vector have direction, scalar do not.
Right. Vectors have direction and scalars do not have any directions. On the other hand, both vector and scalars have magnitude, right? So if you are just asked to write the definitions for it, so the basic definition for scalar would be quantities that have only magnitude. And for vectors, the definition is plain definition is quantities that have both magnitude and directions. Now I have students in A2 batch also that they are not sure what the term magnitude stands for. Can anyone participate and say what is the meaning for magnitude?
A numerical value.
Right, a numerical value, or you can say that the size of the quantity, right? So basically all the things work like a synonym, right? Numerical value or size of the quantity. Now for Edexcel, the problem is that even though they all mean the same thing, right? But you cannot write numerical value or size of the quantity because they are not included in the mark scheme. You obviously have to write your answer using the mark scheme words. So we have to just adjust with the new term magnitude. So if I have to give you an example, like for example, I'm giving an example that the distance between a point A and B is 25 meters, right? For example, this is point A and this is point B, right? So the distance between these 2 points is 25 meter. Now here it has only two things, that is a numerical value and meter is its unit. Now regardless of any category a quantity is categorized into, every quantity will always have their own specific or unique unit, right? If it is a scalar quantity, vector quantity, derived quantity or base quantity, doesn't matter, but every quantity will have their own unit. Now for this one also, this meter stands for the unit for the quantity distance, and this 25 gives you the size of the quantity, like how much big that quantity is, or the numerical value of that quantity, or using our mark scheme word we can say it is the magnitude for the quantity, right? And now if you look up to this, it doesn't say that the distance between A to B, like from A to B is specifically 25 and from B to A it will change. No, right? If you travel from A to B or if you travel from B to A, the distance is going to be same. So the direction here is not a significant matter here. It really doesn't matter in which direction you travel, the distance will be same, 25 meter. So for quantities that really doesn't rely on directions are referred to as scalar quantity. So you have already understood that distance is obviously a scalar quantity because it only has magnitude and no directions involved with it. But if we are to ask about the displacement, right? Displacement is like a vector quantity version for distance. Distance is a scalar quantity version where direction doesn't really matter much, but for displacement, direction is going to be a very important matter. So if you are just going to focus on this example again, the distance between A to B is 25, but if we are about to write displacement, we obviously have to ensure that from which direction, from where point or to which point we are traveling. Like for displacement, we have to write our answer as 25 meter from A to B. Now if you again point out these single things, this meter is again going to be the unit for displacement. This 25 is going to be the unit for magnitude or size or numerical value for the quantity. And now this last part, from A to B, refers to the direction of the quantity. It tells you that specifically from A to B, the distance is going to be 25 meter. So this is the direction. And what is the problem with vector quantities is that whenever we reverse the direction, for example, if you are asked to calculate the displacement for from B to A, right? We have the value for displacement from A to B, but if you are asked to calculate the displacement from B to A, displacement from B to A, we can see that the directions have reversed now. We calculated the value for displacement from A to B, and now we are asked to calculate the value for displacement from B to A. As the directions have reversed, now our value for displacement will also turn into a reverse sign. Like for A to B, the value for displacement was positive 25. So for the displacement from B to A, the displacement would be minus 25 meter. So for vector quantities, whenever the direction is reversed, there is a minus sign. This minus sign doesn't refer to that it is a negative value. No, this minus sign refers to the direction. You can just write vector quantities as like this: 25 meters from A to B, from B to A, or you cannot write all these letters or skip it and just add a minus sign to front of it, and they both mean the same thing. Either you write your displacement as 25 meters from B to A, or you can write just simply minus 25 meter. The negative sign are always used in vector quantities to represent the directions. Is this clear up to this level?
Yes, clear.
Okay, so with this, there are simple stuffs we have already studied, like how vector quantities work and everything. Now in A levels, there is a small problem, that is we are actually dealing with a lot of quantities and everything, and we cannot actually keep a lot of things in our mind. I preferably don't like memorizing stuff. I would obviously prefer you all to memorize some mark scheme points, right? But you cannot always memorize every bit of the information. So what I suggest that you try to understand the concepts and try to involve maths into every topic as much as you can for at least unit 1. Unit 1 is entirely of maths, as I've already stated in the start of our class. So as I was saying, that as we are going to deal with a lot of quantities, and sometimes there will be MCQs containing 1 mark, but the MCQ would be so tricky, you are asked to calculate the value for a certain quantity that you might never heard about, and you need to say that if that quantity is vector or scalar. So in order to know if an unknown quantity is vector or scalar, we perform a dot multiplication. Right, so let me just zoom in. So dot multiplication is actually not that much of a detailed working. You don't need to show the working. These are just needed for the MCQs, for the first 10 MCQs in our section A, unit 1. So for example, in dot multiplication, the rule is that we always refer all these scalar quantities to be of a positive sign, and in case for vector quantities, all the vector quantities are referred to as negative sign. So for example, if you are given a quantity like force, and you have the equation as force equals to mass into acceleration, and now you do not know how to, like, you just forgot that what is the quantity for force, how can you calculate it? You know the basic thing, that is mass is a vector, so is a scalar quantity, so it will be plus, and the acceleration is a vector quantity, so it will be minus, and we are just going to use the simple algebra, that was, if you multiply a minus with a plus, what will be the final result? It will be minus, right? So it says that after the all calculation, the final sign for force is negative, indicating force is a vector quantity. Now if you just move to something of a bigger or like tougher equation, for example, kinetic energy equals to half mv square. The half stands for a numerical value just here, just in this equation, for the sake of formula. So it really doesn't play any role in identifying the type of quantity kinetic energy is, right? So you can just keep half over here. So we are actually working with mass and a square of velocity. So mass is again going to be a scalar quantity plus, and you have to multiply with minus, but there will be a square. Always remember, this is also a basic of math, that whenever you are squaring any negative value, the final would be positive. Why is that? Because squaring means you are multiplying two negatives together, and the final would be plus. So you can write plus for the mass again, but when you square this negative sign, you're going to end up with plus again. And if you multiply a plus with plus, the final sign would be this, right? So this is the final kinetic energy equation, sign for kinetic energy. And as a final sign for kinetic energy is plus, what would be the quantity? Is it going to be scalar or vector?
Scalar,
Scalar. Why is that?
because it's plus, so scalar quantity.
Right, because it has a plus sign, so it's going to be a scalar quantity, right? So can you guys do a little math for me? What is the formula for momentum? It is mass into velocity, right? And another formula is gravitational potential energy, and that is mass, gravitational acceleration, and h, height. So can you all do like simple calculations like this I have done in the screen above, and show me your working to wherever you are connected with me? Like those of you who are connected with me in WhatsApp, can you all like solve this, showing all the working, and then state at the end that this quantity is scalar or vector, and click a picture of that working and send it to me in my WhatsApp or Messenger, wherever you are connected with me. I hope everyone has access to phone, right? Mansifa asked a question that for MGH is G positive, and if it is not, then why it's not positive. I'm going to explain it to you a little later. Let us first others try to solve it, and then if they can't, I'm going to solve your question. Right, get back to your question. Just give me a few minutes. Everyone has that question. Is gravity should be negative or positive? I'm gonna get back to this question in a few minutes. Let us first let others solve the question, and if they can't, then we will try to solve it. Okay, same question for the height as well, yes. Okay, I have only got answer from Ishrat, I guess. Right, Ishrat. Ishrat gonna send me the value for this. Miss, can I leave? Okay, so let me just write it down. For momentum, it's going to be mass and velocity. Mass is obviously positive. It's a scalar quantity, and velocity is a vector quantity, right? So it will be plus multiplied with a minus, and the simple basic algebra is whenever a positive thing is multiplied with negative, the final answer would be minus, right? Indicating that momentum is indeed negative. And then after that, we had gravitational potential energy. So we have a lot of questions for this specific quantity, mass, G, and H. So for here, gravitational acceleration, always remember, doesn't really matter what type of acceleration we're working with. Like we can have deceleration, that is negative acceleration. We can have uniform, constant, steady acceleration. You can have increasing acceleration, decreasing acceleration, or you can have gravitational acceleration. All these terms are added with acceleration. And acceleration is a negative, negative quantity or vector quantity. So obviously, doesn't matter what kind of word is added with acceleration, acceleration will always be a vector quantity. Now, if you still don't understand that why acceleration is a vector quantity, you can use the equation that is A equals to V over T. Velocity is a vector quantity, right? Because obviously velocity depends on directions and everything. So it will be minus over time is a scalar quantity. It really doesn't depend on which direction you're working with, right? So it will be a plus. And again, using the basic of algebra, minus over plus, the final sign would be minus, indicating that acceleration is indeed negative, a vector quantity. So it really doesn't matter what kind of acceleration you're working with. Acceleration is always going to be negative unless you're working with the double motions of kinematics. That's a different case, but in general case, acceleration is always a vector quantity. So here it will be
Apu, can you
mass.
explain the acceleration part again?
Yeah, sure. Which part didn't actually understand? I just said a lot of things.
The full part actually, I didn't hear it.
Okay, sure. So for acceleration, actually, sometimes we do write acceleration as positive, but that's in case for kinematics double motion, right? Like in kinematics double motion, when we are going to move to that topic, you're going to see that for upward motion we refer acceleration to be plus, and for downward motion we refer acceleration to be minus. But that's totally depending on the directions. That really doesn't actually interfere with the actual vector or scalar quantity nature of acceleration. If you are just going to be involved with the fact that if acceleration is a vector quantity or scalar quantity, then you have to use these calculations that I've wrote on the screen. That according to the equation, velocity over time, velocity is a vector quantity, so it will be minus, time is a scalar quantity, so if you divide it, the final sign for acceleration is going to be negative. And this indicates that acceleration is indeed a vector quantity. And as I've stated that so many words can be added before or after acceleration, like there are gravitational acceleration, uniform, constant, steady acceleration, increasing acceleration, decreasing acceleration, or negative acceleration. These terms really doesn't matter because we are just going to focus on the term acceleration. Acceleration is a vector quantity, so anything added before the term acceleration will always be negative because vector quantities are always referred to as negative signs, right? So is it clear now that why accelerations are referred to as negative, or why specifically? Yes. Okay, so for mass we are using plus because it's a scalar quantity, and then you have to multiply it with gravitational acceleration. We have seen that it will be negative. And for height, so for this one specific GPE, we always refer to the directions of height. Here the height doesn't really represent distance but displacement. The height here represents displacement, and we have already seen that displacement is indeed a vector quantity. So here it will be minus. So plus, minus, minus. The final would be mass is positive, and if you multiply two minus together, it will be again plus. So in plus and plus, the final sign for gravitational potential energy is positive. Is my explanation entirely clear for GPE and momentum? Any questions?
Why H is negative?
Why H is negative? H is considered to be negative because we are dealing with displacement here, not distance. Like for whenever we are dealing with the height fallen or height increase by the any object that is moving, right? For example, this is the ground level, and this is the cliff, top of cliff, and a ball was thrown downward. As we can see that the height is decreasing, the GP would decrease, right? Now for this one, the height was specifically taken from this point, right? From this point, the height would be like 5 meter, and as the ball descends, the height, we are saying that the height is decreasing. So we are just obviously taking the direction from ground to cliff. We are never taking the distance from cliff to ground, right? We always say that the height is decreasing. Like we always say that the scenario as the ball falls down the cliff, the height is decreasing. What it means that we are specifically taking the distance from ground to cliff. That means there is a role for direction. Direction obviously plays a very significant role for this one. And whenever we have magnitude with direction, it becomes a vector quantity. So obviously the vector version of distance is displacement. So for gravitational potential energy, we are not actually involved with distance. Here the height fallen is basically displacement. So displacement is a vector quantity. That's why we refer to the height as negative. Is it clear now?
Yes.
Okay, any more questions regarding these things? Or dot multiplication, anything? Is the concept clear for dot multiplication? I would appreciate little answers for this question. Is the explanation for dot multiplication clear?
Yes.
Okay, So I think if dot multiplication is clear, we are going to just move back again to the derived quantities and base quantities. That was this one, right? So another thing that Excel wants you to find is that sometimes you are asked to like break down a derived quantity, like break down a unit for derived quantity into its base units. For example, if you are working with something of a bigger unit like pascals, which quantity's unit is pascal? Are we familiar with the term Pascal? It is a unit for what? What quantity? Okay, so I think we are not familiar with pascals. So we always refer to pascals as PA. The quantity whose unit is pascal is power, right? So power is the unit for pascal. Now Pascal is basically named after the scientist who invented power. Now using the just pascals, you cannot actually understand which quantities are actually involved to calculate the value of a power. So what we do, or what we say, is that Pascal is the derived unit. Like it really doesn't say what it means or what are the quantities that are involved to calculate the value of a power. So what we have to do, we have to use the equation to calculate the derived unit, sorry, not derived, like base unit to power. So for example, for power the equation is force over area. Now area is a base quantity, you cannot break down area into anything simpler, but for force you can break it into anything simpler. That is, force is mass into acceleration over area. Now if you are to write all these things just using their unit, everything look like power equals to force by area. The unit for power is pascals, force is Newton, over area is meter square, right? We already know this from our IGCSEs that 1 Pascal is equal to 1 Newton per meter square. So now if you break down Newton, because obviously it is not a base unit again, Newton can be broken down into simpler units. So it will be pascals. Yes?
Isn't it pressure?
Oh yeah, I'm really sorry. I made a mistake. Yes, it's going to be pressure. Sorry. Yeah, I'm really sorry. I made a confusion. Pressure equals to force by area. So like Pascal is equals to Newton per meter square. You can break down Newton into mass is kg, and for acceleration it will be meter per second square over area is meter square. Now for the numerator, there is going to be a little bit of maths again. I'm going to write the denominator separately and the numerator separately. How can I do that? Is that kg into meter per second square, like this, and this is multiplied with 1 over meter square. Is this working clear up to this level? Any questions up to this level? How did I separate in the m square separately?
No question.
Okay, so now we can write the meter per second square again as a fraction, and it will look like kg into meter per second square into 1 over meter square. So now on the denominators we have s square and m square, so we can write all the numerators together at the numerator position, that is kg into meter, and at the denominator what we have is meter square and second square. So this m cancels out 1 m of the numerator, but we're still left with 1 m at the denominator. So it will look like kg over m s square, and we can write it down as, like, this is a 1, there is an invisible 1 here, right? We obviously never gonna write 1 as a power, but I'm just writing it for the sake of explanation. So we can write it down as kg per meter per second square. So what does Pascal stands for? This is the base unit for Pascal. 1 Pascal is obviously equal to 1 Newton per meter square, or you can write 1 Pascal is equal to kg per meter per second square. This is the derived version, and this is the base version. Is this working entirely clear with you all?
Yes, clear.
Okay, if this is clear, I'm just gonna do a few more maths using this things, and then we are gonna move it. Like, I'm gonna give you one question, and then you all have to solve it. So let's move to.
Apu, what's the duration of the class?
Yes, that's a very big question. Actually, the duration of the class is going to be 1 or 30 minutes, but sometimes I might need like 10 to 15 minutes extra. I hope that's not a problem for any one of you. Even if like you have some work in the morning and you need to sleep early, then you can leave the class after exactly 1 or 30 minutes. But like, if I'm extending the class to 10 or 15 minutes more, then obviously the classes are recorded and you will get the recording. So you can just, leave the class for the last few minutes that I'm going to extend the class for, and then you can just look up at the recording. I hope that's totally fine with you, everyone.
Classes will be in the morning? Or
No. I'm saying that
No.
the classes will be at night. My classes will be at night, but some of you might have schools in the morning, right? And need to sleep early. That's what I'm talking about. My class times are going to be Monday, Wednesday and Friday from 10:30 p.m. Bangladesh time. Any more questions about the class or class time?
no questions?
Okay, so let me just continue my working. I was trying to do similar kind of working for power now, right? The thing I actually started with. So the equation for power is work done by time or energy by time. You can write either of it. Sorry. So the derived unit for power is watt. Right, again named after the scientist who invented power. So the watt unit doesn't actually refer to the units involved to calculate the value for power. So what we will do is that we will derive it and break it down to its base version. So equation of power is work done by time, or you can use energy by time. Regardless of anything you use, the final answer would be same. So I'm going to use two different equations for power, and at the end of the day, and then end of the calculation, you're going to see that the base unit for power is going to be same. For example, I'm using work done by time, and the equation for work done is basically force into displacement over time, right? So if I just write it down using terms of just units, you can write watt is equals to work done is the unit for work done is joules, or any kind of energy. The unit for energy is joules. So joules over time is seconds, and then it will be watt equals to, we are breaking down joules in terms of force and distance, so it will be Newton meter by second, and we can again break down force into mass, acceleration, distance over time, so it will be watt equals to, we can break down Newton as kg per meter second square, kg meter per second square and then we have the m, another m for distance divided by second. And then I'm obviously going to do that same calculation, that is I'm going to separately write the denominator as a different part. So it will look like kg into meter by second square into meter, and then multiplied with 1 by second. So what you have at the numerator is this kg into m over s square into s. So the final thing would look like kg meter square over s cube, and the entire thing will be kg meter square s power minus 3. So this is the unit for watt, right? The base unit for watt. Now if I have to like derive this equation again, but using different type of energy, for example, I'm using gravitational potential energy instead of this one, the equation, sorry, the base unit for watt would be still the same. For example, let me just move to this side and do the same calculation but using the different equation. Power is equals to energy by time. We are using gravitational potential energy over time, and gravitational potential energy can be broken down into mass into gravitational acceleration into height over time. And now we can write it down in terms of just units only, and it will be watt over joules per second. And again it will be, we can break down joules here in terms of mass, gravitational acceleration and height. So it will be kg into meter per second square into height is m over time is s. And obviously we can write again it as, we're writing the denominator separately, so it will be meter over second square into meter into 1 over second. So the entire thing would look like kg meter into meter over second square into second, kg meter square over second square, and it will be kg, so it will be cube over here, and it will be s power minus 3. So you have seen now that I use different equations for both sides. On my left hand side I use the equation as power equal to work done over time. On my right hand side I use the equation energy, gravitational potential energy over time. But even at the end of the calculation, the base unit for watt is still the same. Is there any confusion now?
No.
Okay, if there is no confusion here up to this level, I'm gonna give you one work and you have to just show the derived versions. I have done for pressure and what? Power, right? Okay, I'm gonna give you one of a very big one. Are we familiar with the term potential difference or voltage? What is the equation for voltage?
Current into resistance.
Current into resistance, right? But you don't know the like derived version for resistance, right? Or based unit for resistance. So it's better to not use that equation. Any other equation for voltage?
Energy by charge.
Right, energy by charge. So you can use this equation. So for voltage, I'm writing it in terms potential difference equals to energy by charge, and the simple equations would be V equals to W by Q. Let me tell you, here W represents work done, and the unit for derived unit for voltage is volt, right? VOLT, V. Can you please do the entire working and show me the base unit for volt? Okay, Ishrat has already sent me the picture and it's totally correct. So I'm just gonna wait for a bit and then just do the calculation here on screen. Right, Aisha, you did the calculations totally fine, but you haven't, like, showed all the steps, like how did you get to joules and everything. But that's totally fine. I can understand, like, you take the help from the other working to find the final base unit for joules. So, yeah, your calculation is otherwise totally fine. Okay, so how many people are still in the class? Let me just look at that. Aisha and Ishrat have already sent me the pictures. Mansifa and Farah, do you have any problem? Should I just post you these solutions now on the screen, or you guys are still trying? I think I'm gonna explain it. So, using this equation, we have work done over what? Charge, and the equation for charge is like Q equals to IT, right? Current into time. So it will be like V equals to work done is force into distance over IT, and force can be broken down into mass, acceleration, distance over IT. And current cannot be broken down in anything. We have already stated in at the top of our lecture that current is a base quantity, so we cannot break down current into anything simpler. So we have V equals to mass is kg, acceleration meter per second square, and then a distance is m over as, and we can write as separately. It will be kg into meter per second square into meter into 1 over as. And if you just take all the numerators together, it will be kg. Meter into meter will be meter square, and you are left with a at the denominator and s cube at the denominator. So the final equation would look like kg meter square, a power minus 1 and s power minus 3. I think the entire calculation is clear for you all, right?
Yes.
Okay, so if this is clear, then I don't think so I'm going to explain any more topics now. So up to this, we explained vector quantities, scalar quantities, and base derived quantities, the simple calculations for base derived quantities, dot multiplication, how to understand if a random quantity is a vector or scalar. Up to this, is everything clear? Is there any questions?
No questions.
Okay, if you don't have any questions, then I would like to stop this class now. And from tomorrow, our class is going to start, like 23rd of January. And those of you who want to continue my classes, I've already tell you at the start of our class that you have to confirm me by tonight or by before tomorrow's class. That would be on 10:30 Bangladesh time, and classes will be on Monday, Wednesday, and Friday. Timing will be same for all 3 days, 10:30 p.m. to 12 a.m. and all the class recordings will be provided in the Google Classroom. After you confirm me that you're going to join my classes, I'm going to add you all to the Google Classroom. So I hope my class was very understanding for you all. You understood every topic that I've tried to explain in today's class. And yeah, thank you for joining.
Apu, what is the payment? How much is the payment?
Who are you actually? I can recognize the voice.
Apu, how much is the payment?
Yes, I understand your question, but I've asked who are you? What is your name?
Oh, Ishwar Janvi.
Right, I'll text you the payment in inbox, okay?
Oh, okay. Thank you.
Is there any question that I can answer?
Oh, no, okay.
Okay then, bye bye. Thank you for joining.